Welcome into today's CAD lesson. In today's exercise, we would model this conveyor system. We would also drive or animate just like you saw in the beginning of this video. Let me also mention that this is the third of such tutorial on my channel where we model a conveyor. I would link the other two down in the description box below. You can check them out. If you would have any comments, questions, concerns, or contributions at the end of this, kindly leave them down in the comment section below. I would respond to them as soon as possible. Let's begin with today's exercise. We will begin by drawing the path. So let's get the worksheet. Let's click on new up here. Standard MMIPT we would create. And so this is going to be the path that will serve as the reference for creating the belt and even for the placement of our attachment. You know what attachments are soon. But for now, let's begin to draw this profile. We'll put some points on there and we would continue from there. We would get a clear understanding of why we are doing this later in the video. Now I have a path sheet template opened. Let's begin by clicking on the 2D sketch up here and we would create this sketch on the XY plane. Now let's pick the circle command. We will draw a circle at the origin. The diameter of this circle is 150, so we'll type that in here and press enter. You can double click so you get your work in focus. Okay, you can even use the scroll mouse button. And let's draw another circle here and say make equal this circle, and this circle would also put a vertical constraint, a horizontal constraint between the center point of this circle and this other one here, and dimension the distance between the center point of those two circles as 1000. Let's check that. Now let's pick the line command. Okay, this circle isn't constrained yet. Let me see what is happening. So you just touch on the circle and you drag it. Okay, I think we failed to apply the equal constraint. So let's do that again. Equal, make equal this circle and this very one. Great. Now we pick the line command. Let's draw a line from this point here and connect it to this very one. You can right click OK, but also say make tangent this line, and this circle would also offset. Let's click on this. We'll drag and type in the offset distance of 150, which is the distance between those two lines, and press enter. Now we'll take off some parts. Let's pick the trim command up here, and we want to take off this part of the circle and also this part of the circle. Now that is all we have to do. Let's finish this and scroll so we get our work in focus. Now what we want to do is to put a point here, and we want to use that point to define our next point. So first of all, let's pick the point command and we are going to put a point here. We also want to place another point, but we want that to be 50 millimeters away from this very point here. For that, let's use the parameter up here. So just click on that. Now what we want to do is to put a parameter. See, we have all the dimensions we've inputted so far here, but we want to put in another dimension which we are yet to input. So let's add numeric parameter, and that we're going to call it the drive. Click in here and let's type under the equation 50, which is going to be the length we want to input. Now you want to check this and that and hit done. So let's click on rectangular pattern command, and we want the feature we want to pattern to be this point. And now for the direction, we can choose this very slot we have here. Now we want just 2 as the column count, and here for the column spacing, we want to click here and choose list parameter. We want to define that with the drive we just inputted, which is 50 millimeters. So what we are saying is we want to pattern a point 50 meters away from this very point we put here initially. So just click on the drive and now open up this for more options. For the start, we want the start to be at this very point. So you can just click in there. When you zoom in or look closely, you will see that we've placed a point here, which is 50 millimeters away from this first point. So there we have it. Now we can hit OK. So yes, now we see it clearly. Let's turn off the visibility of the first point. We don't need it anymore. We just needed that as the reference. And now we'll turn back on the visibility of the sketch. We also want to pattern some more of these points along this slot. Those points are going to be for the placement of our attachment. So for that, let's pick the rectangular pattern command again. So the feature we want to pattern is going to be this point here we patterned, and the direction of that is going to be on this slot. Now for the column count, we want 20 of those points. Now we want to say that for these points here, we see a preview of that. We want to define the distance between them with the entire curve length. So we are saying Autodesk Inventor should calculate the length of this slot we have here and put 20 points on it. But for the 20 points, it should also space them equally. That's all we are saying. So it should do the math for us. Now let's open this up for more options. We want the start of those points to be this very point we place here. So just click on that. And for the orientation, we want it to be same as the direction one. And for the compute, we want to choose adjust. So you should make any necessary adjustments to the spacing of these points for a good calculation. Now we hit OK. So you don't see those points, but once you hover your mouse on this rectangular pattern tool you have here, you will see these points. Now this is going to be the path. It will serve as the placement of our attachment, and we would also build our belt based on this path. Now let's save this. I have prepared a folder already. It's called the conveyor with package animation. I'm going to save this as the path. Let's hit save. Okay, now we move on to create the belt. But for the belt, like I mentioned, we want to use this path as the reference. So we want to create a copy of this path, and we would edit that. Let's hit on open. Now let's go into the folder we are working in. And this is the path. So just click on it, right click, and then you would copy, and then you will paste a copy here, right in the same folder. But for this, we are going to change the name. So just click in there, and we would call this the belt. Now you can click outside. Let's select the belt now. So you should see the file name as belt here, and hit open. Okay, so let's make the modifications now. We will delete the rectangular pattern tool, and would also delete. So just click on it and right click and choose the delete option. Even for the work point, we can also delete it, but that's fine. Now let's go into the sketch. So double click on the sketch, and here all we want to do is to offset. So pick the offset command. This slot, we want to offset that inward to a distance of 10 and enter that. Now we would finish this and extrude. So the extrude command, let's extrude this profile here. So between the first slot and the second slot, this very one. And we want the behavior to be asymmetric, and the distance of this extrusion is 200. So we'll type that here under the distance. Then we have the preview. Let's hit OK. So we have our belt as simple as that. Let's hit on save one more time. Now we'll move on to create the shaft. For that, let's get a new worksheet, and so we click on new up here, standard MMIT. Let's create. Now let's pick the 2D sketch command and create this also on the XY plane. Let's first of all measure something in here. So go back into the belt. Let's hit on inspect and measure. We want to measure the diameter of this circle here. So just click in there. The radius is 65, which makes the diameter 130. That is what we want. So hit done. Now let's go back into the shaft part we are creating. Now pick the circle command. Because the shaft is going to go inside that circle, that's why we needed to measure the diameter of that space. So we bring that to the origin, that is the circle, and do a circle of diameter 130 like we measured. Let's enter that. Now we'll finish this, and we want to extrude. The extrude command. The profile is selected. The direction is symmetric. The distance of this extrusion is going to be the same as the extrusion of the belt, which was 200. So I'll type that in here and hit OK. Now let's select this face here and create a sketch on it. Let's pick the circle command and draw our circle here. The diameter of this circle is 50. I'll enter that. Now I'll finish this, and I'm going to extrude that circle to a distance of, let's do 40, and hit OK. Also on this face, I'm going to create another sketch. Pick the circle command. Let's draw a circle of diameter 20. Let's enter. We can finish it as well and extrude that also to a distance of 40. Let's hit OK. Now on this face, let's create a sketch. But I want these extrusions I've done here to be off my way. It is obstructing the view of the face I selected. So I'm going to click on Slice Graphics so I see that face. Now let's pick the circle command from the origin. I'll draw a circle of diameter 85. Let's enter that. You can right click and then OK. Pick the circle. Let's make it constructional. Now let's pick the circle command again. We'll draw a circle here of diameter 20. Let's enter that. And we want to put a vertical constraint between the center point of that circle and the origin. Would also make coincident the center point of that circle and this pitch circle we've drawn here. You can right click and OK. Now let's finish this. And we want to extrude cut that profile. I said extrude cut, so under boolean, let's pick the second one, which is a cut, and we want the depth of that cut to be 5 mm. Let's hit OK. Now I want to create multiples of this extrusion here around this face. For that, I'll pick the circular pattern command. The feature is going to be this one, and then for the rotational axis, it should go around any circular axis. So I can choose this, I can choose that, I can even choose this one. I see the previews. I want the occurrence count to be 6. Let's hit OK. Great. Now I want to pattern this extrusion, that extrusion, and also this extrusion cut on the opposite side. For that, we will choose the mirror command. The features we want to create the mirrors of is going to be this one, that one. Also this extrusion and these circular patterns as well. You could have also selected them from the model browser. So these 4. Now for the plane, I want it to go across. And so for mirror plane, I'll choose the XY plane. There I see the preview. And so I will hit OK. Let me get the isometric view and apply the final detailing, which is the fillet. So the fillet command. A fillet radius of 2 mm is fine. Let me apply it to this edge also, this edge, this very one, and then the opposite sides as well. Let's hit OK. Now I'm going to save this part also, and to save, I will call this as the shaft. Now on to the fourth part, which is the attachments. Let's get a new worksheet for that new standard MMIPT we would create. We'll pick the 2D sketch command and create the sketch on the XY plane. Now let's pick the line command. Let's draw this profile here so you can just watch and do same. We'll draw a perpendicular line to that. Also another perpendicular line. Another one. Okay. Great. Now we have this profile. You can right click and then OK. Now we will dimension. So the dimension command, the length of this line is 5. Also the length of this one is 5. So just click and select the 5 you have here and check. For this, anytime you change this dimension of 5, let's say we change to 7, this will also automatically change. Now for this length also, we'll say 5. Let's check that. Also this specified because of the constraints between this line and this line. So let me cancel that. And now for this also, that is going to be 5. Let's check that. And we want to put a coincident relationship between the midpoint of this line here and the origin. You can right click and then OK, and then the final dimension. And so dimension, the length of this line is going to be 22.5. Let's check that. Now this sketch is ready, so we'll finish it. Let's extrude. The direction is going to be symmetric. The distance of extrusion is 200, which is how wide our belt is. Let's hit OK. Now let's save this as attachment. And we will begin to put these parts together. These are not all the parts. We would later create 2 more parts and add that to our assembly. But for now, for better understanding, let's assemble these 4 we've created so far. So let's get an assembly sheet template, new. This time under assembly, assemble 2D and 3D components, standard MMI-AM. Let's create. Before I do anything, remember we are within the assembly template. Let's go into the view tab, and under the visual style, change that to shaded with edges, which is the 3rd option. Now let's go back into the assembly tab. Now we would hit in place. Let's bring in our first part, and so go into the folder you are working in. For me, this is it. And I'm going to pick the first part, which is going to be the path. So just select that and hit open. Now I'm going to place that here. You can right click and then OK. But we want to constrain this. We want to constrain it to the origins of the assembly. So let's open up the origins of the part, and then we would open that for the assembly. And under relationships, we hit constrain. We want the solution to be a flash, and what we are saying is that flash the YZ plane of the assembly and the YZ plane of the path. Let's hit apply. We'll do same between the XZ and XZ, those two. Let's apply, and then finally XY. Let's hit apply, and we would close this for now. Alright, now we can bring in another part. Before we do that, let me suppress these. Hit on place, and the second part is going to be the attachments, and so I'll select that and hit open. Now let me place the first attachment here. You can right click and then OK. We want to constrain this, and then later we would pattern it along those points we placed. That was the reason why we placed those points. Now let's hit on constrain. We want to constrain the center point of this attachment to this point. So let's find the center point. Let's hit on the plus sign next to the attachment and click on the plus sign next to the origin. Now here we have the center point. This is it. You see it's highlighted here once you touch on that. So there we have it. And we want that to mate with this point here. Let's hit apply and close. But then we see that it's still rotating, it's moving. We want to constrain some more. And so constraint again. Now the type is going to be angle. The solution will be a directed angle. We want to constrain all right, but we want to also be able to move the attachments. That is why we are using the directed angle type relationship. Okay, so for that, let's open the origin of the assembly and that of the attachment. We have that opened already. So we want to put a directed angle between the YZ plane of the assembly and the YZ plane of the attachment. Let's hit apply. And then also the XZ. Remember, it is the type angle, the solution a directed angle, and hit apply. Okay, now let's close this. Let's see. We see that it's fixed, but we will be able to drive it also. Now we want to create a pattern of this attachment. We want 19 more. So making 20, including what we have already, which was the pattern point we did. So pick the pattern command here. The component we want to pattern is going to be this one. And now for the feature pattern select, click on this option. Hit on modeling here next to the assembly. And go into the path. So just click on the plus sign, and here we would find our rectangular pattern. So it's going to be this rectangular pattern too. We want to place the attachments at this point. So just click on that. And here we see that they are rightly placed. Okay, now let's hit OK. Next, we would place in our belt. So click on place. Let's locate the belt. Let's open. We'll drop that here. You can right click and then OK. Let's constrain. The type is going to be a mate, and the solution is going to be a flash. So we open up the origin of the belt. We want to constrain that with the assembly. So YZ, we want to flash the two. Let's hit apply. We'll do XZ. Let's apply, and then XY. Let's apply. Now we can close this, so we see we have that rightly placed. Now let's bring in the last part, not the last part actually, but the last part for this assembly we are doing. So place, that is going to be the shaft. Let's open that. We'll drop one here, and we'll drop the other one on the opposite side. You can right click and then OK. Now we want to constrain concentrically this shaft to this hole here. So select those two. Remember, the type is going to be a mate and the solution is going to be the aligned. Let's hit apply. Let's also put a flash between this face and this face. Let's hit apply. We would also change the solution to a mate and constrain concentrically this and also that hole. Let's apply. And we want to put a flash between this face. Let's pick the flash. So this face and then this. Okay, we selected the wrong face. So let me cancel. Constraint. Let's put the solution as flash between this face and this face. Let's apply and we can close this. Now let me get the isometric view. Let's see what we are dealing with. You should be able to rotate the shafts, likewise this one as well. But we want the two to rotate together at every point in time. So go back into constraint. Now under motion, pick motion actually. And for the solution, it's going to be a forward. For the selection 1, it is going to be this face. The selection 2 is going to be this face. So we want the two to rotate together. That's what we are saying. Let's apply and close this now. See, once we try to rotate one, the other rotates. Now let's put a directed angle constraint between them so we can try. So constraint, the type is angle, solution directed angle. Now let me suppress these. Leave the origin of the assembly opened. Now let's open the origin of the shaft too. And the directed angle is going to be between, let's see, the XZ plane of the assembly and the XZ plane of the shaft too. Let's apply. Now we can close this. You won't be able to drive them anymore because we've put the directed angle constraints, but we can drive them once we get to our environments or Inventor Studios. Yes, so let's go into Inventor Studios and drive. Before we do that, let's change the appearance of this. So for these attachments, just click on them, drop down the appearance. We are going to give this the blue wall paint glossy. And then for the belt, I'm going to do the PETE. It's a white color, and so okay, this one PTFE actually. Let's select that. For these two shafts, hold down Control, select this. We will give those two the horn. So H. Alright, so there we go. Now let's turn off the visibility of the sketch. So hover your mouse on there. You can even pick that from the model browser. So for the path, click on that, right click, and turn off visibility. Now we go into our environment and Inventor Studios. Okay, so there we have it. Now we are within the render tab. Okay, so before we do anything, let's open the animation timeline and hit OK. Now there we have our animation timeline. Once we open this, we see there's nothing in here. There's no animation yet. We would put in our animation. Also, once you click on animation options, you would open the animation option tab. All we want to change is the length of this animation. We want to do just 10 seconds for that. So I'll type that in here and hit OK. Now let's begin to add those parameters we want to animate. So go into parameter favorites. Under this part, remember the 50mm drive we put in there. We have it here, so let's check that and hit OK. Once we hit OK, it would appear here under animation favorites. There we have it. Before that, it wasn't in there. Another parameter we also want to drive is the angular relationship, so we can have our shafts rotating. So let's look for that angular relationship. Click on the plus sign next to the shaft 2. Here we have it angle 3, so just click right click and choose add to favorite. Notice it would be added to animation favorite here once you click on add to favorite. Great, there we have it. These are the two parameters we would animate so we can get to drive this conveyor. Now what we want to do is to click on the angle, right click and choose animate constraints. So here what we are seeing is that let that start at 0 degrees and we want that to end at 720 degrees because we want to do 2 complete revolutions and we want that to be done within a time frame of 10 seconds. So it should start at the 0 second and end at the 10 seconds. Once you enter the end time, the duration would be inputted. Now you can hit OK. So here we have it. We see that our animation has been inputted here. So we have the timer here at the end. Because of this bar we have here at the 10 seconds. Let's bring that to the beginning. You can do that by clicking on this icon here. Here we have the bar at the beginning. Let's hit on play. Let's see what happens. Before that, let me even bring the two shafts in view so we see those two rotating together. Let's hit play now. Okay, but they are rotating in the anti-clockwise direction, which is fine. So you can stop the animation here. Let's take the timer back to the start and you can click on the time span here. So just click, it will turn to this cyan blue color. You can right click and choose edit. Now let's negate the angle. So put negative 720 instead of 720. Let's hit OK. You can take the timer back to the start and hit play. Now we see those shafts are rotating in the clockwise direction. Great. Now let's even stop this. Take the timer to the start. We also want to drive the belt, including the attachment. Let's now click on the drive here, right click, animate parameters. The start of that is 50, which was the start of our first attachment. That is fine. But the end of that, we want to change to 1000. And that should also start at the 0 second. It should end at the 10 second. So we want that drive of 1000 millimeters within a time frame of 10 seconds. Let's hit OK. That animation has also been inputted here. If you want to edit it, you just click right click and choose edit and make the edit you want to do. Now we will take the timer to the start and hit play. Okay, this has been neatly done. But there is something else I want you to do, just like we saw in the beginning of the tutorial. We want to create the illusion of boxes moving along this belt. So let's do that. First of all, you can close this and finish Inventor Studios. So we go back into our assembly sheet templates. From here, we would continue. Before we move on, save this assembly and so just click on the save icon and save it. I've done that, so save, and then you would save it as however name you want it. I kept the assembly1.iam. Great, now we want to move on. So what we want to do is to create the illusion of boxes moving on this conveyor, just like I mentioned. And how we want to tackle this is to create a path for the boxes that will be moving on this conveyor. And the path is going to be built with the reference of this path we created initially. So let's call this the path 1. Now we want to create the path 2 for the moving of the boxes on the conveyor. So let me go back into the assembly, and here let's open. We want to create a copy of this first part we did. So just click on that, copy it, and then you paste, so you get a part copy. I've done that already, that's why we see the part copy here. Once you've copied and pasted, you will see the part copy. Just click on that, and we want to change this to the part 2. Okay, now let's select the part 2 and we would open that. There we have it here. Now let's delete the rectangular pattern 2, and even the rectangular pattern 1 will delete that as well. Now let's go back into the sketch, so double click on that and make a little bit of modification to this. So first of all, we want to delete this circle, and also we won't delete this, but delete this very line. And here let's pick the line command. We will draw a line here. You can right click and then OK, and make tangential this line and this circle. You right click and then OK. Now let's trim off the excess of this line and then also the excess we have here. So we would want our boxes to move this way, so that once it gets to this point, it moves down here as if they are falling. Great. Now let's dimension this. This dimension is there already at 75, and so I'll keep that. The distance between this line and this point here is 75. Let's check that. And then the distance between this point here and this edge is going to be 1600. Let me type that and check. Also, between this point here and the origin is 1350. Okay, we are getting the aligned dimension. I don't know why, but just right click and choose the horizontal. Okay, now we can type in 1350. Let's check that. Great. Now this is going to be our path. Let's finish it. Now we want to place the point for the boxes. We have our first weak point here. Let me click on it, right click, and turn off visibility. Turn it on actually. So we have our first point, and now let's see the placement of the first box. Let's go back into the assembly and look at something. Let me get the front view. We want to place the first box in here, right in between this attachment and that attachment. So we want to place it right here in the middle. We remember that the distance between this first attachment and the intersection of this circle and this line here, which was the first point we placed, was 50 millimeters. I hope you remember that. Now we want to add the 50 millimeters to the distance between this attachment and this attachment, so we get the first box in here. So this is the dimension we are looking at between this point here and this attachment, and between this attachment and the first point we have here. That is the distance we want. Now let's see how we want to do that. Let's place a point here, which was the placement of this attachment. Would also place another point in here, and we would measure. So go to inspect. Let's measure the distance now between this point and this point. We know that that is 1, 2, 3, 5, 6, whatever. So just copy, Control C, highlight and Control C. When we divide that by 2, we will get the midpoint here, and we would add that to the 50 millimeter we also have here to get the placement of our first box. Now, once we have that copied, let's hit done and go back into the part 2. Now let's put our parameter into FX, and rather let me change this actually. So this is the drive. I'll change that to, let's do a calculation. So 50 plus, let's open our bracket, the measured distance. Let me paste that here and divide that by 2. Now I have this checked and that checked. Let me hit done. Now let's place the first point for the placement of our first box, which we would define with the parameter we just imported. So let's go into rectangular pattern. The feature we want to pattern is going to be this point. The direction 1 should be this line, and we want just 2 of them. Also, the distance between those 2 points, we want to define that with the parameter we inputted, which was the drive. Okay, so let me select that again. Let's open this up, and we want the start to be from this very point here. Now we can hit OK. So we have the first point. Let's turn on the visibility of the sketch. So just right click, turn on visibility. Let's turn off the visibility of the first work point. Now we want to also pattern this along. Let's pick the rectangular pattern command. The feature is going to be this point, and we want the direction to be along this line. Here we want 20 of them, and we want the spacing between them to be the measurement we copied. So once you still have it, just paste it here. It should be 123.561 and so on and so forth. Okay, so for the start, we want the start to be from this point here, and we want the orientation to be direction 1. The compute, let's adjust, and now we can hit OK. We see those points once you hover your mouse on the rectangular pattern form. So this is it for the path. Now what we want to create is the box. Let's get a new worksheet for that. Standard MMIPT. Let's hit create. We pick the 2D sketch command and create the sketch on the XY plane. Now let's pick the rectangle command. We will draw a rectangle here, and we will dimension that, and so the length of this is 60. Let's enter that. Let's give that a height, a width actually of 40. Let's enter. Let's put a coincident constraint between the midpoints of this line and the origin. We would finish this and extrude that profile symmetrically. The distance of extrusion is going to be 150. I'll type that in here and hit OK. There it is. We have our box. Let's save this as the package. Great. Now we can go back into the assembly, and so here we are. Let me delete these points. So you can just click on them and delete. Also click here. Let's delete. We just needed it for the dimension between this attachment and that attachment. Let me get the isometric view now. Now we'll bring in the path. First of all, let's right click in here and choose collapse all, so we have a clean model browser. We'll go back into the assembly tab and hit on place. Now we want to bring in the path too, so I'll select that. Let me open, and I will drop that here. You can right click and then OK. Let's constrain it just like we did for the path 1. So open up the origin of the assembly and also that of the path 2. Let's constrain. It's going to be a flash between YZ, YZ. Let's apply XZ, XZ. Let's apply, and then XY, XY. Let's apply. Now we can close this. Let's bring in the package and so place. So we have our package here. I'll select that. Let me open. Let me drop the package here. You can right click and then OK. Now let's constrain. We want to put the center point of this package on this point. So let me suppress these for now and open up the origin of the package and constrain. We want to constrain the type is a mate, the solution is a mate as well, between this center point here and this point. You can apply. Let's close this. Now we want to pattern this along those points, which are the 20 points we placed on the path. So let's hit on pattern. The component is going to be this one. Here for the feature pattern select, let's click on that. Let's open the path 2. We would find the rectangular pattern 4 there. Let's select that So there we have our boxes patterned along, just like we have it. So we'll have about 20 boxes. Okay, you can reduce the number if you want. So there we have it. Now we can hit on OK. Let me turn off the visibility of this part. And so there I have it. Click on it, right click, turn off visibility. And then also let me change the appearance of these pattern boxes. So just select that, go into the appearance, and you can choose the beige natural polish just to mimic a box. Okay, so now we have our boxes. Let's now drive. So we go back into the environment and Inventor Studio. Notice we have our two animation favorites. So this and that, we can even open the animation timeline. Once we click on the plus sign next to them, and even the second plus sign, you'll see the animations we have so far. Now let's add the new one, which will be the drive for the boxes. So parameter favorite. Now here we have the path 2. So just click on that. Here we have our drive. I'll check that. And let's OK. Once you hit OK, you should see that here. The names are the same. That is going to be a little bit confusing, but we will find that. So let me click on this, right click, and choose animate parameters. Okay, this isn't it, so I'll close this. Let me choose the second one, click, right click, and choose animate parameters. We should have changed the name actually. Now the start of this is 111.781, and then for the end we would have to do a little bit of calculation for the right drive. I have done the calculation for you, 1048, just so we can move along and the boxes wouldn't overlap or move in such a way that it won't sit in between the two attachments. So there I have the calculation done. The start is 0. The end, let me do 10 seconds or so. Now let's hit OK. So there we have the animation. Let me take the timer to the start. Now we can hit play. Before we hit play, let me suppress this and even close this further. Let me put this here and open this. Okay, this much is fine. Now let's play. So there we have it. Let me stop this and even reverse. Okay. Okay, let me play again. Awesome. Now you can finish Inventor Studios. Let's do a basic rendering, and so go into the View tab. Let's add some shadows. We'll add a reflection, and we will change the lightning effect to Photo Booth. You can also go into Tools, Application Options, and we want to change the background color. So click on the Color tab here to the presentation. Let's hit Apply and close this. Okay, so there we have it. That will be it for today's tutorial. I hope you find this helpful. If you do, kindly consider giving me a thumbs up and also subscribing if you're yet to do that. If you have any comments, questions, concerns, or contributions, you can drop them down in the comment section below. I will respond to them as soon as possible. Don't forget to share this and also save this. I'll see you soon in the next tutorial. Bye.